Completed, sir.
Then no,
Okay.
sir. Relation between Kc and Kp is not completed.
Not completed, no? Okay. Relation between is not completed.
Sir, you took one equation. Explain, sir.
No?
You have took one equation and you have explained, sir, how to write Kc and Kp.
Okay, okay. Now, I'm taking the one more example for this one. Now, for a generalized equation, this is a x moles of A plus y moles of B is equilibrium with m moles of C and n moles
And
of
moles of D.
we have to express the Kc for this reaction. Okay, is equal to active mass of C whole power m into active mass
whole
of
power
B,
N.
active mass of A, active
Whole
mass
power
of
X.
A, whole power x, active mass of B, whole
Whole
power.
power Y.
If consider these are gaseous components, this is gaseous, this is also gaseous, this is also gaseous, this is also gaseous, children. Now we know that PV is equal to nRT. No? PV is equal to nRT. Now P is equal to means pressure of gas is equal to N by V RT. Now N by V is a concentration CRT. N by V is molar concentration, no? That it is considered as a active mass into RT is equal to P. Children, it's clear now? It's clear.
Yes, sir.
Right. Now I am taking for the example, partial pressure of A means partial pressure of A. I am taking concentration of A. This is C now. C. Concentration of A means active mass of A into RT. Now partial pressure of B means active mass of B into RT. Partial pressure of C is equal to active mass of C into RT. Now, PD, partial pressure of D is equal to active mass of D into RT. It's clear, children. Now, okay. So, Kp for this equation, what we have to write, children? Here, this is Kp is equal to partial pressure of C whole power m into partial pressure of D whole power n upon partial pressure of A whole power x, partial pressure of B power y. Is clear, children. So PC is this one now. This is PC power m means whole power m. Okay na? Clear na?
Yes, sir.
Now partial pressure of so for the example, partial pressure of C power m, we may write, okay, like this. Active mass of C power m and RT whole power m. It's clear na, children? Okay na?
Yes, sir.
Like this, partial pressure of m means active mass of C power m and RT whole power, okay, m into partial pressure of D means right likely this no P power, okay,
Active mass of D power M into RT power M.
n. Active mass of D power n RT whole power n, like this. Now into active mass of D power n into RT whole power n upon partial pressure of that it is A. A means active mass of A power x, and RT whole power x into active mass of B power y into RT whole power y. It is clear, children. Now, this is the RT is common. RT is common. So, this equation is right likely this C power m into D power n into RT whole power m plus n upon active mass of B. So, I am taking A power x, active mass of B power y, then RT whole power x plus y. It's clear, children. Now, this part I am taken as case. So, just wait. Now, this is the part active mass of C whole power m, active mass of D whole power n upon active mass of A power x, active mass of B power y, RT whole power m plus n minus x plus y. It is clear, children. Now, this total part is taken as a Kc. Kc is equal to C power m into D power n. C power m into D power n upon A power x and B power y. So, this total term is taken as Kc. So that Kp is equal to Kc RT. This is taken as delta n. Delta n of gaseous. Right, children. So delta Ng I am taken as delta Ng I am taken as this. Number of moles of gaseous products minus number of moles of gaseous reactants. It's clear now, children? No, it's clear now.
Yes, sir.
Clear, sir.
Yes. I am changing this equation like this for the example. Kp by Kc is equal to RT whole power delta n. It's clear. For the example, H2 plus I2 is equilibrium with 2Hi. This is gaseous, and gaseous. This is 2 moles of Hi gaseous. Means already we told you now that it is delta n is equal to number of moles of gaseous products. Means 2 minus number of moles of gaseous reactants. 1 plus 1, 2 is equal to 0. Okay, now? Now, units for Kc and Kp. Right, children? Units for Kc and Kp. Units for Kc. Units for Kc is concentration whole power delta n. Units for Kp is atmosphere whole power delta n. Right. For the example, what I am taking, children, H2 plus I2 is equilibrium with 2Hi Here delta n is equal to 0. Means concentration power 0. Kc is equal to concentration whole power 0. Concentration power 0 means, okay, something power 0 is equal to 1. 1 means no units. No units. Here. This is also for Kp is equal to atmosphere whole power 0. Means no units. Varshit, clear nama? Varshit.
Yes, sir.
Right. Now going to the second case. Right, children, what I am taking for the example, another example what I am taking. N2 plus 3H2 is equilibrium with 2HI. Sorry, 2NH3. Sorry. 2NH3. This is gaseous. This is also gaseous. This is also gaseous. Now, delta N is equal to, this is 2 moles product minus reactant 3 plus 1, 4 moles is equal to minus 2. For this reaction, units for Kc is equal to concentration whole power minus 2. Means concentration means moles per liter, na? Moles by liter whole square power minus 2. So moles power minus 2 liter square or liter by mole. Okay, this is a square. This is the units of this one.
Bhavita.
Okay, children. Now liter square by mole square like this. So it may be all like this, the liter square mole power minus 2. In case of atmosphere, children, Kp, units for Kp is atmosphere power minus 2 or 1 by atmosphere square. It's clear, na, children? It is clear.
Yes, sir.
Now, if in case positive value means decomposition of ammonia, another example what I am taking, decomposition of ammonia. 2NH3 is equilibrium with N2 plus 3H2. Now this is gaseous, children. This is also gaseous. This is also gaseous. For this equation, delta N is 3 plus 1, 4 minus 2 is equal to 2. Now units for Kc units is concentration square. Okay, that it is moles square, liter square. In case of Kp for the same reaction units, Kp means atmosphere whole square. Right, reminder, children, one more thing is here. Okay, units of Kc or Kp. Units of
Sir, liter power minus 2.
Amma?
Liter power minus 2.
Yes, minus 2. Okay, units of Kc or Kp depends on okay, depends on the delta N. So this point useful for neat entrance point of view. అంటే ఒక ఎగ్జిబిషన్ ఇచ్చేసి వాట్ ఇస్ ద యూనిట్స్ ఆఫ్ కేసీ అని అడగడానికి మనకి ఛాన్స్ ఉంది. సో యూనిట్స్ ఆఫ్ కేసీ ఆర్ కేపీ ఇస్ డిపెండ్స్ అపాన్ డెల్టా ఎన్. ఓకే, వెన్ ఎవర్ delta n is equal to 0, delta n is equal to 0. No units of Kc or Kp. Right. Now let me discuss what is the relation between the Kc and Kp. Now we are moving.
Sir,
Now first question.
no fraction value for n, sir.
Maybe it possible. It is possible. Fractional value is also possible. Okay. Okay now.
Then what will be the case, sir?
We are discussing about the delta n value Kc Kp relation we are taking. Case 1. If delta n is equal to 0, example I am taking children, n2 plus O2 is equilibrium with 2NO. This is gaseous, gaseous, gaseous. Another example, H2 plus I2 is equilibrium with 2HI. This is also gaseous, gaseous, and gaseous. Right, children? In both these cases, delta n is equal to 0. Okay. What is the relation is here? Kp is equal to, now Kp is equal to Kc RT whole power delta n. Now Kp is equal to Kc RT whole power 0. Something power 0 is 1. So that Kp is equal to Kc. Okay. Note point. Whenever delta n is equal to 0, then Kc is equal to K. Okay now? Ma, okay now?
Okay, sir.
Right. Now, I am moving to the second case. Another example I am taking, children. Do you have anybody? Delta n is equal to 0. Delta n is equal to 0. Kc is equal to Kp. Reminder.
Sir, I'm asking that if n is fractional, are there any units for Kc and Kp, sir?
Yes, it is there. What you are getting the delta n value, that it is taken as power. Understand now, Roger?
Yes, sir.
What is the value? What is the value delta n value if you are taking as power? Depends upon negative or positive, whatever. Understand my concept?
Yes, sir, understood.
Right. Now let me discuss case 2. Case 2. Delta n is greater than 0. Delta n is greater than 0. Now let me take children. One more example for this one. Greater than 0. 2NH3 is equilibrium with N2 plus 3H2. This is gaseous, gaseous, gaseous. It's clear. Delta n for this one is 3 plus 1, 4, minus 2 is equal to 2, greater than 0. Another example what I am taking, PCl5 decomposition. PCl3 plus Cl2. All are in the gaseous state. Another example what I am taking, children, NH4HS. Okay, this is a NH3 plus H2S. Gaseous, gaseous, and solid. For this equation, delta n is equal to 2 minus 0 is equal to 2. For this one, 2 minus 1 is equal to 1. In all cases, delta n value is positive, means greater than 0. Then what will be happening? Relation between the Kc and Kp. Then Kp is equal to Kc RT whole power delta n. RT whole power delta n. The delta n value is positive now. Delta n value is positive, means greater than 1. This value should be greater than 1. In that situation, Kc is multiplied with any positive integer. It is equals to this one. So that this is a situation Kp, okay, is greater than Kc. Children, it's clear now?
Clear, sir.
Clear, sir.
Right. So note point. Note. Whenever delta n is greater than 0 or positive, Kp is greater than Kc. Clear. These are all cases. I am writing the relation between these two for this reaction. Kp is equal to Kc RT whole square. Now, Kp upon Kc is equal to RT whole square. Or Kp is equal to, okay, Kc by RT whole power minus 2. Or Kc is equal to Kp upon RT square. Teja?
Sir.
Are you following?
Yes, sir.
Children, anybody doubt regarding this one?
No, sir.
No, sir. No, Lord, sir.
Now, I am moving to the next case 3. Case 3. In this case, delta n is less than 0, that it is negative. For the above reactions are inverted. For the example, what I am taking, children, NH4HS, reverse value you have to take. NH3 plus H2S. Just wait. Okay. NH3 plus H2S. This is gaseous is equilibrium with NH4HS, which is solid. Here delta n is equal to, this is 0 now. So this is a number of moles of gaseous products. 0 minus 1 plus 1, 2 minus 2 is equal to minus 2. For this equation, Kp is equal to Kc, okay, RT whole power minus 2. Means divide cheste deeniki equal avutadi. More than 1. Now, Kc is greater than Kp. Or Kp is less than Kc. Important concept. Whenever delta n is less than 0, then Kp is less than Kc. What did you observe, children? Kp value is directly proportional to delta n value. Clear now? Kp value is directly proportional to delta n value. Ma.
Sir, once check the product side, sir.
This one, NH4HS.
NH4H5 you wrote, sir.
This is NH4 plus HS minus ionic compound.
Okay, sir.
right?
Okay, sir.
This hydrogen is takes up by this one to be converted as NH4 plus, HS minus. Both are electrostatic bond, ionic. Clear na? Now Kp is equal to equals to Kc. Now by RT whole square. Now Kc is equal to Kp into RT square. It's clear na children? Clear?
Yes, sir.
Now here R value is 0.0821 liter ATM mole inverse Kelvin inverse. It's clear. First case, second case, third case. 3 cases. Clear na? Is anybody doubt regarding these cases?
Sir, third case once again, sir.
Not getting na? So one more example what I am taking, children. This is a N2 plus 3H2 is equilibrium with 2NH3. This is gaseous, this is gaseous, this is also gaseous. For this reaction, delta N is equal to 2 minus 4. 2 minus 4 is Ma? Okay, right. Now Kp is equal to Kc. RT whole power delta N means minus. The minus 2 and L are not change. This is Kp is equal to Kc by RT square. Something value to ఇది డివైడ్ చేస్తే ఇది ఈక్వల్ అవుతుంది, లేదా ఈ Kp అనేది ఈక్వల్ అవ్వాలంటే మోర్ దాన్ 1 తో మల్టిప్లై చేయాలి, then it is equals to Kc. So in this situation Kc is greater than Kp or Kp is less than Kc. Rakesh, understand na?
Yes, sir.
Children, anybody?
Yes, sir.
Now let me continue. Types of equilibrium is completed now, homogeneous and heterogeneous.
Yes, sir.
What is homogeneous equilibrium?
No, sir, not completed.
Not completed, sir.
Not completed, sir.
Okay. Types of equilibria. Types of equilibria or equilibrium. Based on physical states of reactants and products. Reactants and products. It is in two types. First one is homogeneous. Second one is heterogeneous. Homogeneous and heterogeneous. Homogeneous and heterogeneous. What is homogeneous and what is heterogeneous? Let me discuss here. Homogeneous equilibrium means homogeneous equilibrium means equilibrium in which both reactants and products are in the single phase or same phase. Means equilibrium is in single phase. Simply, equilibrium is in single phase. That means reactants and products are in same phase. It's clear, children. Our equilibrium system is in single phase. Simply. Example, what I am taking, N2 plus 3H2 is equilibrium with 2NH3. This is gaseous. This is gaseous. This is also gaseous. Now all are in the same physical state. Another example, what I am taking, children, this is acetic acid, CH3COOH, and ethyl alcohol, C2H5OH, reacts with each other in acid medium, means aqueous, to forming the ethyl acetate. H2A is liquid, means aqueous condition, aqueous condition, aqueous condition, aqueous condition. Means these all are in same state, means liquid state. All reactants and products are in the liquid state. Here, reactant and products are in the gaseous state. So, better examples for homogeneous equilibrium. Children, it's clear, Nama?
Yes, sir.
Reactants and products have been gaseous, sir.
Ma?
Single phase.
Ma?
Reactants and products should be in gaseous, sir. If single phase means
Yes. Should be in gaseous or should be in a liquid state. This is liquid. Aqueous means liquid state, liquid state, liquid state, liquid state, and liquid. All are in the liquid state. Both reactant and products are in the same, whatever, either liquid state or in a gaseous state. Do not change with the state of the reactants and the products. So that equilibrium is called as a homogeneous equilibrium. Children, it's clear now?
yes, sir.
Carbon monoxide, gaseous, combines with oxygen, gaseous, to forming the carbon dioxide. Okay. So one more example I am taking. Another more example I am taking for gaseous. 2SO3, 2SO2 combines with O2 to forming the 2SO3. Gaseous, gaseous, and gaseous. All are in the same physical state now. That's why it is called as homogeneous. Children, it's clear now?
Clear.
Yes. Yes. Now heterogeneous. Heterogeneous equilibrium. Heterogeneous equilibrium. Then what is heterogeneous equilibrium, children? Let me discuss now. Simply, reactants and products are not in same phase, are different phase. Reactants and products are in a different phase, are not in same phase. It is called as heterogeneous. For the example, I am heating the calcium carbonate, limestone solid. On heating, to form quicklime solid
Plus
and
CO2 gas.
equal to gas. These two are solid. This is gas. So it is an example of heterogeneous equilibrium. Another better example for this one, NH4HS on heating gives rise NH3 plus H2S, which is gaseous, and solid. This is H2S gaseous. One more example, 2KClO3 is equilibrium with 2KCl plus 3O2. This is a gaseous, solid, and solid. This is gas solid different phase, gas solid different, gas solid different phase. Better example for heterogeneous equilibrium. Children, it's clear now? Children, it's clear. So one more example pieces on how to write the Kc Kp value. Okay, example pieces. Later we have to go to the what are the factors that influence the or affecting the Kc or Kp. Now, example what I am taking, children. This is a N2 plus 3H2 is equilibrium with 2NH3. We know that all are in the gaseous state, gaseous and gaseous. This is also gaseous. Now, Kp is equal to Kc RT, okay, power minus 2. Kp is equal to Kc by RT square. Now, Kc is equal to Kp into RT square, or Kc is equal to Kp by RT whole power minus 2. Children, these all our relations are correct or incorrect for this given equation? Correct. Right. Now, let me go to the factors that affecting the Kc or Kp values. Factors affecting equilibrium constant, either Kc or Kp. Kc or Kp, not Kc by Kp. This is Kc or Kp. It's clear. Now the first one is a direction or mode of reaction. Mode of reaction. So how it is affecting the direction of the reaction, Kc or Kp. Now I am taking the simplest example. A is equilibrium with B. For this reaction, equilibrium constant Kc. This is. Now for the reaction, mode of reaction, direction changing, B to A. For this reaction, this is considered as Kc dash. Then what is the relation between Kc and Kc dash? Now, reminder children, Kc is equal to 1 by Kc dash, or Kc dash is equal to 1 upon Kc, inverse value. Reminder, whenever forward reaction is x, Kc value, for reverse reaction is 1 by x. Banu, understand the concept?
Good, sir.
Right. Now I am taking this another example. I am taking a problem for this one. For a reaction, A is equilibrium with B. Kc is X. What is the Kc for the reaction? For the reaction, B gives A.
X power minus 1, sir.
X power minus 1. Nothing but 1 by X. Okay. A is equilibrium with B. For this reaction, Kc is equal to X. Then B is equilibrium with A. This is Kc dash is equal to 1 by Kc. 1 by Kc means 1 by X or X power minus 1. It's clear, na children?
Once again.
Once again, I have to say, yes, I am taking the one more example for this one. Kc for H2 plus I2 is equilibrium with 2Hi is 0.1. What is the Kc of 2Hi is equilibrium with H2 plus I2? Reaction is reversed now. Reaction is reversed. Now, solution, my solution. H2 plus I2 is equilibrium with 2Hi. Kc is equal to 0.1. Then for 2Hi is equilibrium with H2 plus I2, considered as Kc dash is equal to 1 by Kc is equal to 1 by 0.1 is equal to 10. Clear now?
Yes, sir.
Right. Understand now, Rakesh?
Yes, sir.
Now, this is the epic
roll up, sir.
Children, copy it fast. Clear? I will share in the group, children. I will share in the group classwork.
Okay, sir.
Right. Now, what I am saying, children. The first case, mode of reaction is completed. The second one is stoichiometric coefficient. Stoichiometric coefficients. Of reactants. For forward reaction is reactant, backward reaction is product. Whatever. Right. Let me discuss. For the example, what I am taking, children, this is A is equilibrium with B. For this reaction is Kc. Now, this A is multiplied by, this equation is multiplied by N, then is equilibrium with NB, then Kc dash is there now. What is the relation between these two? Now, Kc dash is equal to, so this equation kada, equation is multiplied by N. So you got it Kc dash, new constant, that it is equal Kc. Equation kada no enta multiply chesindi, so power emaitadi nana N. Kc power N. Clear na? Clear now? I am taking the one more example for this one. Okay. A reaction, reversible reaction. C is equilibrium with okay, D. Okay. Its Kc is 10. Its Kc is 10. What is the Kc of the reaction? D is equilibrium with C. Right, inverse na? So sorry. Direction changed. Now 2C is equilibrium with 2D. Now this is a Kc dash anukundam manam. Dash is equal to. So this equation is multiplied by 2
10
na?
power 2, sir.
Kc square. That is 10 square is nothing but 100. Banu, understand Natali?
Understood, sir.
Yes. Are you following? This is the most important models for NEET examination. Clear now?
సార్ నాకు అర్థం కాదు.
Children, anybody doubt?
Yes, sir.
ఏం లేదు తల్లి ఇక్కడ. ఫర్ ఎగ్జాంపుల్ ఐఎమ్ టేకింగ్ వన్ మోర్ ఎగ్జాంపుల్ ఫర్ దిస్ వన్. ఓకే, సో ఒక రియాక్షన్ తీసేసుకున్నాం మనం. ఆ రియాక్షన్ ఏంటన్నా A is equilibrium with B అనుకున్నాం. ఇట్స్ కేసీ వాల్యూ is X అనుకుంటున్నాం. ద సేమ్ ఈక్వేషన్, ఇదే ఈక్వేషన్ ని మనం ఏం చేస్తున్నాం నాన్న, వీఆర్ మల్టిప్లైడ్ బై విత్ సమ్ Y అనుకుందాం. ఏదైనా ఇంటీజర్ తీసేసుకో. ఇక్కడ ఇదే ఈక్వేషన్ ని ఎంతతో మల్టిప్లై చేస్తున్నాం నాన్న, Y తో మల్టిప్లై చేస్తున్నాం అనుకో. దెన్ న్యూగా వచ్చే కాన్స్టెంట్ ఇది ఒకటి కాదు కదా, ఇక్కడ ఇంకొక కాన్స్టెంట్ క్రియేట్ అవుతుంది. దానికి KCX అనుకుంటున్నాం, K డాష్ అనుకుంటున్నాం. ఇది ఎలా ఉంటదంటే, సో ఆల్రెడీ ఉన్న రియాక్షన్ ఉంది కదా, దిస్ రియాక్షన్ కి కోఎఫిషియెంట్స్ పవరే కదా అయింది నీకు. కేసీ రాసుకునేటప్పుడు ఏం చేసినావు, ఎక్స్ మోల్స్ ఆఫ్ ఏ తీసుకున్నప్పుడు ఏమైంది, కేసీ రాసేటప్పుడు ఏ కాన్సన్ట్రేషన్ పవర్ ఎక్స్ అవ్వలే, అయిందా లేదా? కేసీ ఏమైందన్న, కేసీ ఈజ్ ఈక్వల్ టు దీని పవర్ ఎక్స్ అయింది కదా, ఈ ఎక్స్ ఇటువైపు వచ్చింది అంతే, ఏం లేదు, అదే డిఫరెన్స్, పవర్ ఎక్స్ అవుతుంది. నా కేసీ డాష్ తీసేసుకున్నాం. కేసీ డాష్ ఈజ్ ఈక్వల్ టు కేసీ పవర్ ఎంతతో మల్టిప్లై చేసిందమ్మా, వై, పవర్ వై. Now Kc is equal to here, what is the value, X power Y. Clear na? ఒక న్యూమెరికల్ సాల్వ్ చేయాలా, అర్థమైందా చెప్పండి? ఇట్స్ క్లియర్?
Yes, sir.
Yes, sir.
Clear, sir.
Clear. Right, children. What I am taking for the more example for this one. Right, now what I am taking, this is the equation. A is equilibrium with D. This is Kc. Now 1/2A is equilibrium with 1/2D. This is Kc dash. Okay. What is the relation between Kc and Kc dash? Is equal to Kc dash, my first option. My second option is Kc is equal to Kc dash square. Now my another option is Kc is equal to Kc dash whole power 1/2. My fourth option is okay, that it is Kc is equal to 1/2 Kc dash. Children, what is your answer?
Option 2.
Option
3.
very good Davina.
Option 3, sir.
Option 3 is correct answer. No, I didn't
Sir, option 2 no, sir.
Yes, Kc dash is equal to KC dash is equal to ikkada KC this is KC not KC. Okay, KC whole power 1/2. Children, it's clear now? Here no dot.
Yes, sir.
Sir,
Now,
but
this
this
is-
is given option 2, no, sir.
Option 2 కాదు తల్లి. It's a reverse value is okay. Option 2 కూడా కరెక్టే అవుతుంది. KC is equal to okay KC dash okay నా whole power. నేను దీన్ని చేంజ్ అయ్యేటట్టు నోట్ చేస్తున్నాను ఈక్వేషన్. This is a KC dash KC dash okay. This is KC is equal to KC 1/2. Now this is correct answer. Clear now?
Clear, sir.
Yes.
Yes, sir.
Anybody down? Is anybody?
No, sir.
Now I'm question is asking children. In case of A is equilibrium with D, this is 1/2 D is equilibrium with 1/2 A. This is X. KC is equal to X. Here for new constant, KC dash is equal to how much?
X power 1.
X power 1.
X power 2, sir.
So KC dash is equal to, so this is a reverse reaction na? Reverse 1/KC. So దీన్ని ఎంతతో మల్టిప్లై చేసినాం మన సేమ్ ఈక్వేషన్ ని 1/2 whole power 1/2. So KC is taken as X value 1/X whole power 1/2 is equal to 1/√X. It's clear. Okay, now understand the concept.
Yes, sir.
This is a not same reaction. This is a reversed reaction, means inverse value and divided by 2 or multiplied by 1/2. It's clear, Nama?
Yes, sir.
Okay, children, more problems and next relations, how they are interrelated with each other, and other problems will continue in the next class. Children. Thank you. This is our class for today. Next, we will meet by the next class.
Sir,
Thank
what
you.
is final syllabus?
Sir, what is unit test syllabus, sir?
Unit test syllabus is okay. Redox reaction. Next, thermodynamics. Next, thermochemistry. Next, states of matter. That's it. Okay, na?
Okay,
Okay,
sir.
sir. Thank you, sir.
Basic concepts add. Basic concepts add na?
No, sir.
No, sir. 4 and
Okay. Right. children.
Thank you, sir.
Thank you.
Thank you, sir.
Right. Ma.
Sir, will you send key for DPP, sir?
DPP already I sent you na?
Key, sir.
Key na? Okay. Check చేస్తాను. I haven't key. చూద్దాం ఒకసారి key ఉంది. Okay.
Thank you, sir.
I will.
Thank you, sir.
Right.